Yo, welcome back. All right, this is Mr. Martin. We're on 3.5. We are almost done with this unit. We are going to stick with these systems of equations, but this time we're going to use what we call the elimination method. Okay, so we've solved systems before. We've done graphing. We've done substitution. Within that, we've had regular single solutions. We've had no solution. We've also had all real number solutions. So we're going to continue on with those same type of solution sets. That's something that you need to remember. So when we crack into our things to know, at any point, go ahead and pause these. Make sure you got all of these parts written down in your notes, as they are very important. All right, so the first thing that we want to know with the elimination method is there is a specific criteria that we need to meet in order to actually eliminate, and that's going to be these two things right here. In order for us to eliminate a term, we're going to need the same value coefficient. Okay, so a 6, we're going to need a 6. A 7, we're going to need a 7. Okay, and then we're going to need opposite signs, right? And the reason that we need that is, like, if we had a positive 7 and a negative 7, what does that give us? That gives us that 0, so we are actually eliminating these values. So always, always, always think about these two things when you work with the elimination method. We're going to need the same value coefficient, and we're going to need opposite signs. Okay, so the next part to remember, and I talked about it a little bit just a couple seconds ago, is that we might have one solution, we might have no solution, and we might have infinite many solutions or all real numbers. And remember, these are when your variable disappears. Okay, so always, always, always work with those variable terms first, and then say, hey, if they disappeared, I'm looking for that true or false statement, and then I can figure out which one I'm using, and I am good to go. And then remember, if it is one solution, we write that as an ordered pair. All right, so similar to the substitution, the way that we are presented with these systems, it's very, very important that we take a look at them before we start working, so that way we know how best to work these out. And there are 4 different ways you're going to see these types, and I'm going to go through an example of each one with you here. So the first one, okay, is where we would just add straight up. Okay, we got both of our equations lined up, and we're just going to do some simple addition, and we're going to be able to eliminate one of those variables. Okay, another way we might see it is where we're going to subtract straight up. Okay, and this is where our signs will change. Okay, we might see a system where we need to manipulate one equation through multiplication. So we're going to change one of the equations, and then we might run across one where we need to multiply both equations. So we're actually going to have 2 changes that are presented to us. Okay, so I also have this again, I just talked about it a little bit, but remember, a true statement when your variables disappear is that infinite solutions, and a false statement is our no solution. All right, so let's go through these. There's only 4 of them, so I'm going to try and be quick. The first one that we're going to see is where we have that add straight up. Okay, so remember the 2 criteria we're looking for. We have an x and a y, so we're looking, do I have 2 x terms that have the same value coefficient but opposite signs? So I like to kind of look down on my x values first and then my y values. I always like to line them up in standard form. That way I can see them real easily. Okay, so let's look at our x terms first. Do I have the same value coefficient? No, I do not. Here I have a 4. Here I have a -2. So then I look at my y terms. I have a 4 and a 4. That fills that same value. I got a -4 and a +4. So I have opposite signs for my coefficients. So now I am good to go. I can actually do the elimination. So since these ones are already presented this way, this is why we have the add straight up. We can just add these 2 equations together, and we will actually eliminate one of these variables. So let's go ahead and do that. We got 4x plus -2x. That's the same as -2x. So we're going to end up with a 2x here. -4y plus +4y is going to give me that 0. And then I got 4 plus negative 12. That's the same as 4 minus 12. That's going to give me this negative 8. Okay, now you can see we've gotten rid of the y term. We are now down to just an x term. We can go ahead and solve this like we've always solved. We're going to divide both sides by 2, and we get x is equal to negative 4. Really simple. All right, now that we found our x value, we're going to do substitution like we learned in the last lesson. We're just going to pick either one of these equations and substitute that x value so we can find our y value, and I'm going to do that off to the side right here. So we always substitute in parentheses, and then I got this minus 4y is equal to 4. Distribute out, we get negative 16 minus 4y is equal to 4. I can add this 16 to both sides and get my y term by itself. So that is now negative 4y is equal to 20. And then we divide by this negative 4. And we get y equals negative 5. Very good. So now we found our ordered pair. We got our x value, our y value. We write this in an ordered pair with a set of parentheses. Make it good to go. And then we box it up. Okay, so remember, if you have the same value coefficient with opposite signs, you can just go ahead and add straight up. Okay, all right, let's take a look at type number 2. Okay, this is our subtract straight up. This is where we have the same value coefficient, but we do not have opposite signs. So if we take a look, always start with your x's, then with your y's. Here I got a 6, here I got a 1, so the x's won't work. Here I got a 1, here I got a 1. I got the same value, but I do not have opposite signs. So if you have the same value, but you do not have opposite signs, this is where you would want to subtract straight up. And remember, this subtraction is going to distribute to each of these terms. Okay, so it's kind of helpful if you just say it out loud, and then you get an idea if you're actually subtracting or if those subtractions are turning into additions by that negative times a negative rule that we have. So here we got a negative 6 minus a negative, and anytime you say minus a negative, we are going to actually do addition. So this is the same as negative 6x plus 1x, and that is going to give me a negative 5x. Okay, then we have this negative y, okay, minus a negative y, so that's the same as negative 1y plus 1y, and that's going to give me that 0. And then I got this 13 minus a positive 3, and that's just 13 minus 3. That's going to give me that value of 10. Now I'm down to just my x variable. I can go ahead and solve by dividing both sides by 5, and I'm left with x is equal to negative 2. All right, now that we got that, we can plug this into either equation. Let's go ahead and plug it into this bottom one. So I'm going to put this minus sign, then I put this parenthesis, and I plug in my negative 2. Then we got minus y is equal to 3. Negative times negative 2 is the same as positive 2. We got minus y equals 3. We're going to subtract this 2 from both sides. I get negative y equals 1. But remember, I'm not done. Anytime I got a negative variable, I got to divide by that negative 1 and get that into a positive. All right, very good. So now we got that x, we got that y. We are in the place to be. Negative 2 comma negative 1. Put those parentheses around it. Box it up. Boom. Move on to the next one. All right, example number 3. Okay, this is where we're going to have one change because we do not have the same coefficients on either of these terms. We got a 2, we got a 6, we got a 6, we got a 4. Since none of them are the same, we're going to have to change one of these equations. And the reason that there's only one, okay, I want you to think of this little tip. Okay, maybe write this in. Maybe a good way to think about it is small number into big number. Okay, this is a good way to figure out if you need to only multiply one equation or if you might need to multiply both. Okay, we're actually going to change our x terms, but I want to show you why this works. Okay, so if you looked at your y terms and you ask yourself, which one is the smaller y term, the top equation or the bottom equation? Well, 4 is smaller than 6, so we ask ourselves, can my smaller number 4 divide evenly into my bigger number? Can 4 go into 6 evenly? No, it cannot, so we want to leave these alone for now. But what about this? Can this 2 go into 6? It sure can. 6 divided by 2 is 3. Okay, so remember, we need the same value and we need opposite signs. Okay, right now, if we look at our signs for these x terms, they're already opposite. We just need to turn this -2 into a -6. And how can I turn a -2 into a -6? Well, if I multiply it by a +3, that will turn it into a -6. So I'm doing what I call manipulating this first equation through multiplication. I'm going to change this value by multiplying all these terms by 3. So we get 3 times -2x, that is a -6x. 3 times 6y is a +18y. And 3 times -26 is -78. Okay, so now I can do this add straight up. I'm just going to move this one over because now I got the same coefficient, opposite signs, and I am in the place to be. So let's go ahead and write this out. We want these lined up so we can add these really easily. -6x plus 6x gives me that 0. 18y plus 4y gives me a 22y. And -78 minus 10 is going to give me a -88. Because remember, negative plus negative, I'm going to add those up and keep the negative. Okay, then we divide both sides by 22, and I get y is equal to -4. All right, so now that I found my y term, boom, I can go back, find my x term. I'm just going to use either one of these. Let's go ahead and use this bottom one. So I got 6x plus 4 times -4 is equal to -10. So we drop this down. 4 times -4, that's -16 equals -10. Then I got to add this 16 to both sides. And I get 6x is equal to +6. And then I get x is equal to +1. And we are finished. Not too bad, right? I think a lot of you guys are going to like elimination much better than substitution, and that is okay, but it is very important that we learn all the methods that we can use to solve a systems of equations. All right, so now we're down to the last one. This is where we might need to multiply both equations. Maybe not might. This one we actually do need to multiply both equations. So we're going to actually have two changes. Two of these equations are going to change, and we can figure this out by doing that small number into the big number trick. So I asked myself, for my x terms, what's my small number? That's the 7. Can 7 go into 10? No, it cannot. So I move over to my y's. Can my small number 3 go into 8? No, it cannot. So now I got to figure out how can I make both of them get one of those variables with the same value coefficient but opposite signs. So if we take a look at our signs, positive, 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 that lets me know I need to multiply one of these at least by a negative. So I'm just going to choose. Doesn't really matter which one you choose. Everybody's work will probably look different. Okay, I'm just going to do it to this first one. Okay, and a good way to find these common multiples, right? Remember we did this when we add and subtract fractions. A good way to do this is to choose one of these numbers. Like we can turn 7 and 10. A common multiple between those would be what? 70, and we found that by multiplying 7 times 10. So I'm going to multiply this 7 by a -10, and I'm going to multiply this 10 by a +7, because remember I want opposite signs. Alright, so let's go ahead and distribute this, and you'll see how our x terms will be the ones that get eliminated. 7x times -10, that is -70x. 3y times -10, this -10 is -30y. And then -10 times -10 is equal to +100. Down below, I'm going to multiply 7 times 10x. Remember, I'm going to add straight up afterwards. 7 times 10x is 70x. 7 times 8y is positive 56y. And then 7 times negative 18 is negative 126. All right, so let's go ahead and add these straight up. Negative 70x plus 70x, that gives me that 0. We got negative 30 plus 56. That's the same as 56 minus 30, so I get positive 26y. And then 100 minus 126, that's going to be a negative 26. Divide both sides by 26, and we get y is equal to negative 1. Okay, now that I got that y value, let's plug it into either one of these. I'm going to use this top one, so I got 7 times negative 1. Oops, sorry. We have the y value, 7x plus 3 times negative 1 is equal to negative 10. And then we just solve like we've been solving every day. I know you guys love it. I love it as much as you guys do. It's my favorite thing to do in the world. Negative 10 plus 3 gives me that negative 7. Divide both sides by 7. We get negative 1, also one of my favorite numbers. And we got a matching set right here. Negative 1, negative 1. Boom and done. All right, so that is it for my lesson today. Remember, there are 4 different ways you can see this. You're either going to add straight up, subtract straight up, multiply one of those equations so you can add straight up, or you might need to multiply both of those equations so you can get them at the same value, opposite sign, and then just add straight up. All right, so try these problems, get a bunch of practice in. That's all it takes. Remember, ask a friend, ask a family member, ask your teacher, ask a neighbor, ask somebody down the street, ask anybody. They might know how to do these. They might be able to help you with these, and you will be good to go because there is a mastery check coming up. All right, that is my time. This is Mr. Martin's Math Corner. Peace out.